Hello guys, this video is the final assignment of my project, namely tall building design for the Skyfi Labs online course. In this video, I will be explaining the working of the project, which includes definition, analysis and design of the given tall building in industrial software ETABS version 2018. The tall building taken into context will be a 23-storied building with varying geometry from 1 to 8, 9 to 14, 15 to 19, 20 to 23 stories having similar plan details. Materials used will be M40 concrete, HYSD 500, mild 250 rebars. The frame sections available will be of slab with 150 mm thickness of M40 grade concrete, while for beam and column auto select tool of ETABS software will be used to choose the optimal cross section as per the analysis results. Available sections for beams and columns are mentioned in this dialog as 500 by 500, 550 by 550, 600 by 600 for columns, and for beams 500 by 300, 550 by 350, 600 by 400. Regarding the loads, load cases will be dead, live and wind load that will be applicable on the building, including the self weight of the structural elements. Common dead load of 2 kN per meter square will be applied for all the stories, while as the live load will be varying for the similar stories mentioned as 5 kN per meter square for this case, for 4.5 for 3.5 respectively for the similar story cases. The wind load will be considered and taken into consideration as per the Bangalore region of India. This project in ETABS will be progressed in 5 main steps, starting with the definition of geometry, material, section and loads. Those defined parameters are then assigned properly to the building. Next step will be running the analysis on the basis of load pattern to obtain the load action in terms of BMD, SFD, stresses and deformed shape, etc. On the basis of analysis results, a design is run to check for safe dimensions of elements, different elements like beams, columns and slabs. Finally, as output, detailing and summary will be generated by ETABS for the purpose of execution of the work. After the problem statement, let me start with the interface of the ETABS version 18. As I have already created the model for the given building, so I will be going for open existing model and opening the already saved file. So far I have already defined the geometry of the building, and on the left side we have the plan and on the right side we have the 3D elevation of the building. Following this, I will be explaining the 4 basic steps including definition of parameters, assignment, analysis and the design, with more focus on analysis and the design part. So far I have already defined the geometry of the building, and on the left side we have the plan and on the right side we have the 3D elevation of the building. Starting with the first step, definition includes defining of the materials. I have added M40 grade concrete and HYSD 500 and a mild 250 grade rebars. After this, going to the definition of the sectional properties. In the frame sections, I have added the available section in the problem statement as B 500 by 300, B 500 by 550 by 350, B 600 by 400, and the 4 of the columns I have added C 500 by 500, C 550 by 550 and C 600 by 600 columns. Along with this, the slab needs to be defined, so in the slab section I will be adding the slab 150 mm sectional property. So the last definition required is the load case definition. So in the load case menu I have added the dead load, live load and wind load as per the problem statement. After all these definitions, our building is ready for the analysis. So in the analyze menu, click on the run analysis or press F5 button simply. So in the left corner we have the dialog box showing the analysis progress. We'll be waiting for the analysis as it is the big building. After the analysis is complete, we can visualize different load actions on the building like deformed shape like this. We can visualize other things like bending moment diagrams, shear force diagrams by choosing the force diagrams and going through the frame forces. In this, if we want to see the bending moment diagram, choosing the moment 3-3, applying, we will get the bending moment for each and every frame element. You can see this. Or even the shear force diagrams will be available with this analysis option. Now the analysis is complete and I can proceed for the design check of the given concrete frame. Before going to start the design check, I will be setting the preference as per the Indian Standard Code IS 456-2000. After this, I can directly run the design check by clicking Start Design Check or by pressing the Shift plus F6 key. Design process will take some time, and as the output, the cross section of beams and columns will be checked if safe as per the analysis or not. Design check is complete and we can see the reinforcement details which are required for each and every frame section in the 3D view. In addition, we can check that if every element is safe, we can go to design, then concrete frame design, then verify all members pass. This notification signifies that every frame has passed, that is every column and beam has passed the design loads and the analysis results. With this, the design of the tall building is complete, and as the output, we will be getting the project report in this format, which includes structure data, properties, assignments, loads, analysis, as well as the details of the reinforcement that are required for the execution. Thank you for watching this video, and at last I would like to acknowledge Skyfi Labs for this wonderful structural and foundation analysis course.